August 12, 1944, Normandy, France. Colonel Emerson Itchner stood in his tent, reading an order that made no engineering sense whatsoever. General Patton has broken through and is striking rapidly for Paris. His tanks won't run without gas. Therefore, the railroad must be constructed to Le Mans by Tuesday midnight. Today is Saturday. Itchner looked at his watch. 75 hours to rebuild 135 miles of destroyed railway through war-torn France. Every engineer said it was impossible. In 3 days, 10,000 American railway troops would prove them wrong and change the course of World War II. The stakes could not have been higher. By August 1944, Allied forces had finally broken out of the Normandy lodgment after 2 months of brutal fighting. General George Patton's Third Army was racing eastward, exploiting the gap in German defenses created by Operation Cobra. His armored divisions consumed 336,500 gallons of gasoline every single day. Without fuel, the tanks stopped. Without tanks, the breakout stalled. Without the breakout, the war continued. And continuation meant casualties, 50,000 Allied soldiers killed or wounded for every additional month the war dragged on. The arithmetic was brutal and simple. Trucks could not sustain Patton's advance. The famous Red Ball Express, convoys of 6,000 trucks running supplies from Normandy beaches to the front, carried 12,000 tons per day at its peak. But the Red Ball consumed almost as much fuel as it delivered. Each truck burned 1 gallon of gasoline for every 40 gallons transported. The 300-mile round trip from the beaches to the front ate enormous amounts of fuel just moving fuel. The trucks themselves became fuel consumers, competing with the tanks they were supposed to supply. It was logistically self-defeating. Motor transport had its place for short hauls and final delivery to combat units. But for long-distance bulk freight, only railways could move the volume required. A single freight train could carry what 400 trucks carried. A locomotive consumed fuel at 1/10 the rate per ton-mile compared to motor transport. One train crew could move as much cargo as 400 truck drivers. The efficiency advantages were overwhelming. The US Army knew this. They had learned the lessons of World War I when railways moved millions of American troops across France. After that war, the Army created the Military Railway Service specifically to operate captured railways in occupied territory. The MES was organized around an innovative affiliation program. Major American railroad companies sponsored reserve units. Union Pacific Railroad sponsored railway battalions staffed by Union Pacific employees. Southern Pacific Railroad did the same. Pennsylvania Railroad, New York Central, Chicago, and Northwestern. All the major carriers participated. When war came, these railroad men were inducted into the Army with their specialized skills intact. Locomotive engineers became Army engineers. Dispatchers became Army dispatchers. Track maintenance crews became Army track crews. The system preserved expertise that would have taken years to train from scratch. By 1944, the Military Railway Service had 43,500 soldier railroaders, men who had worked for every major American railway before the war. They knew how to run trains in peacetime. Now they would learn to run them under fire. They knew how to maintain locomotives, repair track, operate switching yards, and coordinate complex train movements. But first, someone had to rebuild the tracks. That job belonged to the US Army Corps of Engineers. And in northern France in August 1944, that meant Colonel Emerson C. Itchner. The destruction before D-Day, the French railway system was one of Europe's finest. France had 26,000 miles of standard gauge track. Many lines were double-tracked for simultaneous bidirectional operations. The system connected every major city, port, and industrial center. French rolling stock was older and lighter than American equipment, but the infrastructure was excellent. The railways moved commerce, carried passengers, and supported an advanced industrial economy. German forces had used these same railways extensively during their 1940 conquest of France. The interconnected network allowed rapid troop movements and logistical support. After occupation, the railways became an integral part of German military infrastructure. Then came the transportation plan. General Dwight D. Eisenhower, Supreme Commander of Allied forces, made a decision that caused bitter controversy among his subordinates and political leaders. He ordered American and British strategic bombers, aircraft designed to destroy German cities and factories, to instead attack French railways. British Prime Minister Winston Churchill objected strenuously. He worried about French civilian casualties and the political implications of bombing Allied territory. Air Marshal Arthur Bomber Harris, commander of RAF Bomber Command, protested that diverting bombers from German industrial targets would prolong the war. General Karl Tui Spaatz, commander of U.S. strategic air forces in Europe, argued that oil refineries were better targets. Eisenhower overruled them all. The plan was brilliant and ruthless. Germany's entire defensive strategy depended on moving reinforcements by rail to wherever the Allies landed. If the railways were destroyed, German reserves couldn't reach the battlefield in time. Field Marshal Erwin Rommel, commanding German forces in France, needed to move panzer divisions quickly to crush the invasion before it could establish a secure lodgment. His strategy required intact railways. Eisenhower intended to deny him that capability. Between March and June 1944, more than 30,000 tons of bombs fell on French rail targets. Allied bombers struck marshalling yards, locomotive repair shops, bridges, tunnels, switching stations, and classification yards. The 8th Air Force dropped bombs on rail centers in northern France. RAF Bomber Command attacked targets in Belgium and France. The 9th Air Force provided tactical air support, hitting rail lines near the coast. The campaign worked with devastating effectiveness. By D-Day on June 6, 1944, French railway capacity had dropped to just 10% of pre-war levels. Rail traffic in northern France fell from 58,000 tons per day in March to barely 25,000 tons by May. Track mileage available for operations dropped from 236,000 miles to 62,000 miles. The Germans tried desperately to repair the damage. Field Marshal Gerd von Rundstedt pulled 18,000 workers off construction of the Atlantic Wall defenses. These workers had been building concrete bunkers, laying minefields, and constructing beach obstacles. Now they were reassigned to railway reconstruction. Rundstedt transferred another 10,000 workers to the rails in May. It made no difference. Allied aircraft attacked the repair crews as fast as they worked. Bombers returned to targets that had been repaired, destroying them again. The Germans couldn't keep up. The French resistance added to the chaos. The Resistance Fer, railway resistance, was composed of French railway workers from the SNCF National Railway. These men and women had detailed knowledge of the system. They knew which bridges were critical, which marshalling yards were essential, which repair facilities were irreplaceable. They sabotaged their own infrastructure with surgical precision. Between April and May 1944, resistance fighters destroyed 1,800 locomotives through sabotage. When combined with the 2,400 locomotives destroyed by Allied bombers, Germany simply ran out of working engines. Resistance operatives cut tracks, damaged switches, misdirected trains, and caused accidents that delayed German military transports by hours or days. They poured sand into locomotive bearings. They removed critical bolts from rail connections, causing derailments. They provided detailed damage assessments to Allied intelligence, helping bombers target the most important facilities. In May 1944 alone, resistance groups sent 3,000 written reports and 700 wireless reports to the Allies. The intelligence was invaluable. 150 resistance fair agents were shot by the Germans for their activities. Approximately 500 more were deported to concentration camps. Half of those deported died in captivity, but their sacrifice achieved its purpose. For D-Day, this sabotage was critical. Of 3 panzer divisions stationed near Normandy, only one, the 21st Panzer, engaged on D-Day itself. The 12th SS Panzer Division didn't arrive until June 7th. Panzer Lehr didn't reach the battlefield until June 9th, 3 days late. Under normal circumstances, these divisions could have reached Normandy in 12 hours by rail. Instead, they took 3 days, moving by road through bombed-out infrastructure and under constant air attack. The delays gave Allied forces time to establish their beachhead. By the time German reinforcements arrived in strength, the lodgment was secure. But the destruction of French railways created an enormous problem for the Allies themselves once they broke out of Normandy. The same railways they had bombed and the resistance had sabotaged were the same railways they now needed to supply their armies. The irony was not lost on the engineers who now had to rebuild what Allied forces had spent months destroying. Cherbourg, June 28, 1944. American forces finally captured the port of Cherbourg after a desperate German defense that lasted 3 weeks. Hitler had ordered the garrison to resist to the last man and destroy the port facilities completely. The plan was simple: use Cherbourg as the main supply port and ship everything by rail to the advancing armies. When U.S. Army engineers entered the city, they found a masterpiece of systematic destruction. The German garrison had spent weeks preparing the port for demolition. Engineers had meticulously placed explosives throughout the facility. The 3 main deep-water piers, Quai du Normandie, Quai du France, and Quai du Homais, were blocked with sunken hulks, demolished cranes, and tons of concrete blasted on top of the wreckage. The entire arsenal area was expertly destroyed. Thousands of magnetic, acoustic, and contact mines floated in the harbor and littered the shoreline. Every crane was blown up or toppled into the water. Warehouses were burned or demolished. The harbor entrance was blocked with scuttled ships. American engineers surveyed the damage and estimated it would take 3 months to make the port operational. But the railway situation was surprisingly better than expected. 15 miles of track inside Cherbourg were relatively intact. Several locomotives, including 6 General Pershing 280 steam engines given to France after World War I, were found undamaged in rail yards. A quantity of rolling stock survived intact. Freight cars, tankers, and flat cars that could be put into service immediately. Most importantly, a collapsed tunnel was the only major obstruction on the main line heading south. The Germans had blown the tunnel, but the damage could be bypassed or repaired relatively quickly. U.S. Army engineers went to work with characteristic American speed. They cleared roads, removed mines, repaired bridges, and rebuilt track. The Corps of Engineers brought specialized equipment from England: Bailey bridge sections, locomotive cranes, rail-laying machinery, welding equipment, and thousands of tons of steel rails and timber ties arrived by ship. Colonel Sidney H. Bingham, manager of the New York City subway system in peacetime, devised a breathing bridge to unload railway cars directly from LSTs onto the beach. A flange-wheeled ramp connected to rails laid inside landing ship tank vessels. The ramp extended down to the low tide line, adjusting with the tide. As the tide went out, the ramp extended. As the tide came in, the ramp retracted. It was called a breathing bridge because it moved with the tides like breathing. By July 8th, Bingham had 4 breathing bridges operating at the Terre-Plein area. Each could unload 22 rail cars in 21 minutes. The system worked brilliantly. Locomotives shipped from the United States rolled off freighters at Cherbourg's docks and went immediately into service. The 740th Railway Operating Battalion, staffed by Southern Pacific Railroad men in peacetime, began running trains south from Cherbourg to supply depots. By late July, the railway was carrying significant tonnage. Trains ran day and night, moving ammunition, fuel, rations, medical supplies, and replacement troops. But it wasn't enough. The front lines were still 300 miles away. The single rail line from Cherbourg could carry only a fraction of what the advancing armies needed. And General Patton was about to make his move. The breakout, July 25, 1944, Operation Cobra shattered German defenses west of St. Lo. More than 2,400 Allied bombers and fighter bombers pounded German positions in a concentrated area. General J. Lawton Collins' 7th Corps punched through the devastated German lines and opened a corridor. Patton's Third Army poured through the gap like water through a broken dam. By August 1st, American forces had captured Avranches, the gateway to Brittany and the road to Paris. Patton didn't slow down. He divided his forces, sending some to capture Brittany's ports, while the main body raced eastward. His armored columns moved at speeds unprecedented in modern warfare. Some units advanced 50 miles in a single day. In just 19 days, Allied forces advanced through 260 phase lines. Terrain features that planners had estimated would take 260 days to reach, according to the original Operation Overlord schedule. The planners had predicted the Allies would reach the Seine River by D-Day +90, early September. Patton reached it in early August. The advance moved so fast that supply lines couldn't keep up. Fuel became the critical constraint. Patton's tanks consumed gasoline faster than trucks could deliver it. His Third Army had 12 divisions on the move simultaneously. Each armored division included hundreds of tanks, thousands of trucks, and countless other vehicles. All running on gasoline. The Red Bull Express operated around the clock, but the mathematics were working against success. On August 29th, at the peak of operations, 132 truck companies with 5,958 vehicles carried supplies along dedicated one-way routes from Normandy to the front. Military police directed traffic at intervals. Signs warned, "Stay alive, keep to the right, keep going." The trucks ran bumper to bumper in endless convoys. Drivers operated on strict schedules with mandatory rest periods, but exhaustion was constant. Some drivers fell asleep at the wheel and crashed. Others were killed when their trucks overturned on rough roads or when they were attacked by German stragglers. The system worked, but barely. As Patton advanced eastward, the distance from supply dumps to the front grew longer. Each additional mile meant more fuel burned, just transporting fuel. The Red Bull Express was consuming itself. By August 12th, the situation reached crisis point. Patton's Third Army had 4 bridgeheads across the Seine, 30 miles south of Paris. His tanks were ready to drive on Paris, then Belgium, then Germany itself. Some of his commanders believed they could reach the Rhine River by September if they maintained momentum. The German army was in disarray, retreating in chaos. This was the opportunity to end the war in 1944. But Patton's fuel tanks were nearly empty. His tanks could move only as far as their gasoline allowed. Without an immediate solution, the breakout would stall. The German army would have time to regroup and establish new defensive lines. The Siegfried Line fortifications along Germany's western border would be manned and reinforced. The opportunity to end the war in 1944 would be lost. That's when Patton sent the impossible order to Colonel Itchner. The impossible order, August 12, 1944. 18 p.m. Colonel Emerson Itchner read the order again, trying to find some way it made sense. build a railroad from Cherbourg to Le Mans, 135 miles, in 75 hours. Itchner was 41 years old, a lifelong military engineer from Chicago. He had graduated from West Point in 1924 and been commissioned in the Corps of Engineers. He obtained a civil engineering degree from Cornell University in 1926. He had served with the Alaska Road Commission, building roads through some of the most challenging terrain in North America. He had taught at the Missouri School of Mines. After Pearl Harbor, he supervised Army airfield construction across the United States, overseeing the crash building program that created dozens of training bases in months. Now he commanded the Army Corps of Engineers in northern France, responsible for all construction and reconstruction in the Allied rear areas. He was experienced, competent, and realistic about what engineering could accomplish. And this order was impossible, he calculated quickly. 75 hours meant less than 2 hours per mile of track, including bridge reconstruction, roadbed repair, rail replacement, and tie installation. His engineering regiments had been working on the Cherbourg to Pont-au-Beau line for weeks. They were still far from complete. At sunset on August 12th, 2,000 Corps of Engineers and Railway Operating Battalion troops were working non-stop on repairs near Foligny alone. That was just one 20-mile section of the route, and it still wasn't finished. For the Le Mans mission, Itchner had the 347th and 332nd Engineer General Service Regiments immediately available. He could call up the 392nd, 390th, and 95th Engineer Regiments, another 7,000 men. Total available workforce, approximately 10,000 engineers. The order said, use 1 man per foot to make repairs if necessary. Itchner did the math. 135 miles equals 712,800 feet. He had 10,000 men. That meant 14 men per 100 feet of track. It might just barely be possible if everything went perfectly. If every bridge could be repaired quickly, if they had enough Bailey Bridge sections, if the timber supplies held out, if the rail stockpiles were sufficient, if the men didn't collapse from exhaustion, if German stragglers didn't interfere, if no unforeseen obstacles appeared, if. But orders were orders. Patton needed fuel, the war needed Patton to keep moving. Itchner would find a way or die trying. At first light on August 13th, Itchner climbed into a tiny Piper Cub reconnaissance aircraft. He needed to survey the route and determine which rail line could be rebuilt fastest. The pilot was a young lieutenant who had never flown under fire before. "Sir, the Germans still have snipers all through this area." "I know," Itchner said. "We'll keep low and fast." The pilot nodded nervously and opened the throttle. The Piper Cub lifted off and headed south, staying below 200 feet to spot ground obstacles. German snipers still controlled pockets of territory throughout the hedgerow country. Shots rang out as the Piper Cub buzzed over the countryside. Small arms fire cracked past the aircraft. The pilot jerked the controls, dodging and weaving. Itchner ignored the shooting and focused on the tracks below. He took notes on a clipboard, sketching damage points and calculating repair requirements. The main line from Cherbourg through Foligny to Le Mans was the obvious choice. It was double-tracked, properly graded, and built for heavy traffic. The roadbed was solid, the alignment was good, and it followed the most direct route. But as Itchner flew over the line, his heart sank. The high viaduct at Laval had been destroyed. The bridge was a massive stone structure spanning a river valley, at least 200 feet long and 80 feet high. Several arches had been blown out by German engineers. Reconstruction would require specialized equipment, skilled masons, and weeks of work. The main line was unusable. "Fly west," Itchner told his pilot. "Show me the branch lines." The pilot banked the Piper Cub and followed Itchner's directions. Itchner directed his pilot to follow secondary branch lines through the countryside. He traced a possible route through the forests and hedgerows of southern Normandy, Pont-au-Beau to Saint-Hilaire-du-Harcouët, south to Fougères, east to Mayenne, then rejoining the main line east of Laval into Le Mans. This route was single-track, normally serving just a couple of passenger trains per day, carrying locals to market towns. The roadbed was narrower, the curves sharper, the grades steeper, but it was possible. 5 bridges were down. The most serious was an 80-foot span at Saint-Hilaire-du-Harcouët, where the railway crossed a river. The Germans had blown the steel truss bridge completely, dropping it into the water. But Itchner had Bailey bridge sections, prefabricated steel bridge components developed by the British that could be assembled rapidly without heavy equipment. Bailey bridges were designed for military roads, but with reinforcement they could carry railway loads. Itchner calculated weights in his head. A locomotive weighed about 120 tons. Freight cars added another 40 tons each when loaded. Bailey bridges could handle 40-ton tanks if properly reinforced. With timber struts and extra steel, they might support a locomotive. Barely. He believed all 5 bridges could be repaired in time. Barely. The Piper Cub took more ground fire near Mayenne. A bullet punched through the fabric fuselage 6 inches from Itchner's head. The pilot flinched but held course. "Sir, we should get out of here." "One more pass," Itchner said. "I need to see the approaches to Le Mans." The pilot gritted his teeth and made the final pass. Itchner studied the terrain, noting rail yards, water towers, and coal facilities that would be needed. "All right," he finally said, "take us back." The pilot didn't need to be told twice. The Piper Cub climbed and turned north, heading back to base. Itchner landed and issued orders immediately. All available engineer regiments would converge on the route. Work would proceed simultaneously at all trouble spots. 5 bridge sites, dozens of damaged track sections, blown switches, destroyed signals. Supply trucks would deliver Bailey bridge sections, timber, rails, ties, spikes, and tools to each worksite. Engineer companies would work in continuous shifts, 24 hours a day with no breaks, except to eat and briefly rest. Floodlights would illuminate night work. Time was measured in hours, then minutes. 75 hours to do 3 months' work. Itchner's staff looked at him like he was insane. "Sir, it's not possible." "It has to be possible," Itchner said quietly. "Patton's tanks won't move without fuel. The war won't end without Patton. Make it happen." The Engineering Miracle, August 13, 1944. Dawn. Elements of 3 engineer regiments began arriving piecemeal along the 135-mile route. The 392nd Engineers took the northernmost section near Pont-au-Beau. The 390th Engineers covered the middle sections through Saint-Hilaire and Fougères. The 95th Engineers worked the southern approaches to Le Mans. The 347th and 332nd Engineers, already in the area, attacked the worst damage points, the 5 bridge sites that would make or break the entire project. 9,000 men spread across 135 miles of track. By noon on August 13th, all units were in position and working. They worked in continuous shifts, 24 hours a day with no breaks. At each damage site, engineers assessed the problem and began immediate repairs. Blown rails, cut new rails from stockpiles transported from Cherbourg, drill bolt holes with hand-powered augers, install fish plates to join rail sections, spike the rails to ties with sledgehammers. Every spike had to be driven perfectly. Too loose and the rail would shift under train weight. Too tight and the rail couldn't expand with temperature changes. Missing ties, cut timber from nearby forests with cross-cut saws. Trim to standard length, drill spike holes. Install under rails with cant and spacing precisely measured. Each tie had to be positioned exactly. Spacing too wide caused rails to spread. Spacing too narrow wasted timber. Washed out roadbed. bring up gravel in trucks, spread by hand with shovels, compact with tamping tools and heavy rollers. The roadbed had to be level within a quarter-inch, or trains would derail at speed. Destroyed bridges. Assemble Bailey Bridge sections on approaches, launch across gaps using special launching equipment, install timber struts for locomotive weight. Bailey bridges were engineering marvels, standardized steel panels that bolted together like an enormous erector set. Each panel weighed 600 pounds and required 6 men to carry. The bridge at Saint-Hilaire-du-Harcouët was the worst challenge. An 80-foot steel truss bridge had been blown into the river by German engineers. Twisted metal lay in the water like a broken skeleton. Engineers brought up Bailey Bridge sections, dozens of panels, each weighing several hundred pounds. 20 men carried each section into position on both sides of the river. Assembly required precision. Each panel connected to the next with steel pins that had to align perfectly. Mistakes meant dismantling entire sections and starting over. The Bailey Bridge system was designed for military roads carrying 40-ton tanks, not railways carrying 120-ton locomotives. But with reinforcement, it might work. Engineers calculated load distributions and stress points. They doubled the number of panels, creating a reinforced structure. They added steel crossbeams every 6 feet instead of every 12 feet. Engineers worked through the night assembling the bridge. Portable floodlights, powered by gasoline generators, illuminated the worksite. The lights attracted German attention. Artillery shells fell near the bridge site twice during the night. Both times, engineers scattered for cover, then returned to work when the shelling stopped. Welders worked by torchlight, their welding arcs bright in the darkness. Riveters hammered steel plates together, the sound echoing across the river. Timber crews cut massive beams to reinforce the structure underneath. 12-inch square timbers, 20 feet long, weighing hundreds of pounds each. These timber struts would carry part of the locomotive's weight, transferring it through the Bailey Bridge to the stone abutments on either side of the river. At another location, a concrete arch railway bridge over a highway south of Coutances had been demolished by German engineers. 3 of the 7 arches were intact, but 4 in the middle had been destroyed. The 347th Engineers launched a 50-foot Bailey unit to span the gap where the missing arches had been. Then they installed timber struts just below the Bailey unit to resist lateral thrust from the adjacent intact arches. When a locomotive crossed, its weight would press down on the Bailey Bridge, which would press down on the timber struts, which would push outward against the remaining concrete arches. The forces had to be perfectly balanced, or the structure would collapse. It was engineering improvisation at its finest, combining British Bailey Bridge technology with American timber reinforcement and French masonry in a hybrid structure that existed nowhere in any engineering manual. All along the 135-mile route, similar scenes played out. Engineers filled bomb craters with gravel and compacted earth. They rebuilt destroyed switching stations, installing new switch points and control mechanisms. They repaired signal systems, though these remained primitive. Most signals would be GIs standing beside the track with flashlights or cigarette lighters. They tested every section of track for structural integrity, walking the rails and bouncing on ties to check for weakness. There were no safety margins. Everything was built to minimum standards necessary to get trains through. Proper reconstruction would come later, after the war moved east. Right now, only one thing mattered: Patton's fuel. The engineers worked without sleep. Some men collapsed from exhaustion after 30 hours of continuous work and were carried to the side while their comrades continued. Medics administered stimulants, caffeine pills and strong coffee to keep men working. Injuries were common. crushed fingers from sledgehammers missing spikes and hitting hands, strained backs from lifting 100-pound rails, cuts from sharp metal edges on rail sections and bridge panels. Welders suffered eye burns from arc flashes. Medics treated the wounded on site and sent them back to work if they could stand. Serious injuries, broken bones, severe burns, deep lacerations meant evacuation to field hospitals. But most men worked through minor injuries. There was no time for rest. The clock was ticking. Every hour that passed brought them closer to Patton's deadline. Every section of track completed brought them closer to victory. 0 hour, August 15th, 1944. 8 p.m., 6 hours remained until Patton's midnight deadline. Colonel Itchner flew the route one final time in his Piper Cub. The sun was setting, casting long shadows across the French countryside. The summer evening was beautiful. Golden light filtered through clouds, birds sang in the trees, farmers worked in fields that had been battlefields weeks before. But Itchner saw only the railway. At the Saint-Hilaire Bridge, he saw something that made him smile despite his exhaustion. His engineers had laid out a message in white cement next to the bridge. "We'll finish at 2000. 8 p.m., exactly on time. As Itchner's aircraft passed over, he saw the final Bailey Bridge section being bolted into place. Engineers scrambled off the structure as a test locomotive approached from the north. The locomotive was an American-built 2-8 Nero consolidation type, shipped from the United States specifically for French service. The engineer throttled forward slowly, watching the track ahead. The locomotive's weight, 122 tons fully loaded with water and coal, settled onto the bridge. Steel creaked, timber groaned. The Bailey Bridge panels flexed slightly under the load. The timber struts underneath compressed, transferring force to the stone abutments. But the bridge held. The locomotive crossed successfully and continued down the line. Whistle blowing in triumph. Engineers on the ground cheered. Some men collapsed in relief, sitting beside the track they had worked 60 hours straight to complete. At 9 p.m., the first complete supply train assembled at Cherbourg. 25 freight cars loaded with jerry cans full of gasoline. Each jerry can, a German innovation the Allies had copied and improved, held 5 gallons. Each freight car carried 200 jerry cans secured with rope and wooden bracing to prevent shifting during transport. 25 cars meant 25,000 gallons of fuel, enough to move an armored division 50 miles. The locomotive engineer was Sergeant John Murphy, who had driven freight trains for the Southern Pacific Railroad in California before the war. He had moved supplies across the Sierra Nevada mountains in blizzards. He had handled runaway trains on steep grades. He had dealt with every railroad emergency in peacetime. But he had never driven a train through a war zone on hastily repaired track with no signals, no dispatcher, and no communication system. A major gave him his orders. "Sergeant, get this fuel to Le Mans. Don't stop for anything unless you derail. If you see Germans, run them down. If you take fire, keep going. Patton needs this fuel by midnight. Understood?" Murphy nodded. "Understood, sir." He climbed into the cab and checked his gauges. Boiler pressure, 180 pounds per square inch. Good. Water level, 3/4 full. Adequate for 135 miles. Coal tender, full, more than enough. Murphy opened the throttle. The locomotive's drive wheels spun briefly on the rails, then caught traction. The train lurched forward into the darkness. There were no signal lights, no dispatcher controlled the route via telegraph, no telephone system communicated train locations. At irregular intervals, a GI stood beside the track, holding up a cigarette lighter in the dark. That was the only signal system. A flickering orange flame, meaning, all clear, keep going. Murphy drove by instinct, experience, and hope. He had studied the route on a hand-drawn map, during the brief time he had before departure. He knew where the curves were, where the grades were steep, where the bridges crossed rivers. But seeing it on paper and driving it in darkness were two different things. The hastily repaired track was rough. Rails didn't align perfectly at joints, causing jarring bumps. The locomotive swayed and bounced. Murphy held the throttle steady, maintaining 25 miles per hour, fast enough to reach Le Mans on time, slow enough to avoid derailing on imperfect track. Behind him, 25 freight cars clanked and swayed. Jerry cans sloshed and rattled despite the rope securing them. Murphy prayed the ropes would hold. If the load shifted, the cars could derail. At the Saint-Hilaire bridge, Murphy slowed to 10 miles per hour. He could see the improvised structure in his headlight beam. Steel Bailey panels gleaming, timber struts underneath, the gap of the river visible through the open structure. He could hear the temporary bridge creaking under the locomotive's 122-ton weight. Steel groaned, timber squeaked. Murphy held his breath and maintained steady throttle. The locomotive crossed slowly, drive wheels turning steadily. The freight cars followed one by one, each adding strain to the improvised structure. 25 cars crossed successfully. The bridge held. Murphy released his breath and opened the throttle again, accelerating into the forest beyond. Darkness surrounded the train completely. No moon, overcast sky blocked the stars. The locomotive's headlight illuminated only 200 feet ahead, just enough to see the next curve. Murphy leaned out of the cab window, watching for the next signal. He saw nothing but blackness. Then, a tiny orange flame flickered beside the track, held by a GI standing in the weeds. Murphy waved acknowledgement and continued. Mile after mile, the train pressed forward through the French countryside, past destroyed villages, past abandoned German positions, past fields scarred by bomb craters, past forests where combat had raged weeks before. The war had moved east, leaving wreckage behind. Now the train brought fuel to push the war farther east still. At 11:45 p.m., 15 minutes before Patton's midnight deadline, the locomotive rolled into Le Mans station. The station master was standing on the platform, waiting. He had received word that a train was coming, but he didn't believe it. He stared in disbelief as the locomotive came to a stop, steam hissing, brakes squealing. Murphy set the brake and climbed down from the cab. The station master approached, shaking his head. "This is impossible, monsieur. You cannot have come from Cherbourg. The bridges on the main line are destroyed. I saw them myself. The viaduct at Laval, 3 arches blown out. It cannot be repaired in weeks." Murphy laughed, exhausted but triumphant. "We didn't use the main line, Frenchie. We came through the back roads." The station master looked at the 25 freight cars loaded with jerry cans. "Tell that to General Patton," Murphy added. The station master smiled despite himself. "Mon Dieu, les Américains sont fous. But thank God you are." The supply cascade, August 16 to 25, 1944. Once the first train proved the route was operational, the floodgates opened. Train after train rolled from Cherbourg to Le Mans. Every 6 hours, another supply train departed Cherbourg. By August 20th, trains were running every 3 hours. By August 25, the railway was carrying thousands of tons per day. Gasoline flowed to Patton's tanks in endless jerry cans. Ammunition reached artillery batteries, 155-meter shells by the thousands, smaller caliber rounds by the millions. Food supplies fed advancing troops, C rations, K rations, bread baked in mobile bakeries, fresh meat when available. Medical supplies reached field hospitals, morphine, sulfur powder, plasma, bandages, surgical instruments. Replacement troops arrived to fill gaps in combat units depleted by casualties. Mail from home traveled on the trains, maintaining morale. Everything an army needed to fight moved on the rails. The Third Army didn't stop. Patton's tanks pushed eastward with renewed vigor, no longer constrained by fuel shortages. On August 25, 1944, Patton's forces entered Paris. The City of Light was liberated after 4 years of German occupation. French civilians celebrated in the streets. American soldiers were kissed by grateful Parisians. General Charles de Gaulle marched down the Champs-Élysées in triumph. The railway system had made it possible. Without the 135-mile railroad built in 75 hours, Patton's tanks would have run dry east of the Seine. Without Patton's tanks, Paris would have remained occupied for months longer. Without Paris's liberation in August, the entire timetable of the European campaign would have shifted. But the railway story didn't end at Le Mans. As Allied forces advanced deeper into France, Belgium, and eventually Germany, the railway reconstruction effort expanded exponentially. The military railway service deployed more units to France every week. By late 1944, 26 engineer general service regiments worked on European railways. 50,000 British and American troops rebuilt and operated railways across France. The Second Military Railway Service, responsible for operations in Western Europe, eventually transported 2.3 billion ton-miles of freight. That represented approximately 75% of all American freight moved in the European theater. The statistics were staggering. At peak operations, the Second MRs operated over 6,000 miles of railway in France, Belgium, Luxembourg, and Germany. They operated 6,000 locomotives, American, British, French, and captured German engines. They ran 100,000 railway cars of all types. They employed 50,000 soldiers and 90,000 civilian workers, French, Belgian, Dutch, and German civilians working under Allied supervision. They ran trains into territories barely secured by combat forces. German artillery sometimes shelled active rail lines. Saboteurs, German stay-behind units, and die-hard Nazis attacked trains and bridges. Hastily built austerity-class locomotives, cheap, rapidly produced engines built for wartime service, occasionally suffered boiler explosions from overpressure or metal fatigue. Some explosions caused fatalities, killing engineers and firemen instantly. Safety standards were lax because speed mattered more than caution. But the trains kept running, even under fire, even with casualties, even when exhausted crews worked 18-hour shifts. The trains kept running, because armies require constant supply. A modern mechanized army cannot stop moving. It requires fuel continuously, ammunition constantly, food daily. Stop the trains, and the army stops. Stop the army, and the war drags on. The railway troops understood this viscerally. Every train delivered meant another step toward victory. Every delay meant more soldiers dying at the front, so they kept the trains running. The September Crisis. September 1944. The rapid advance that liberated Paris in August slowed dramatically in September. The problem was logistics. Allied armies had reached the German border, but their supply lines stretched back 400 miles to Normandy beaches and Cherbourg. The port of Antwerp in Belgium was captured on September 4th by British and Canadian forces. Antwerp was the second busiest port in Europe before the war. It had 29 miles of quays along the Scheldt River. It had 322 hydraulic cranes and 270 electric cranes for unloading ships. It had 900 warehouses for storing supplies. It had petroleum storage facilities holding 100 million gallons. It had excellent rail connections to the interior. Antwerp could handle 40,000 tons of cargo per day, more than all the Normandy beaches combined. But there was a problem. The approaches through the Scheldt estuary remained in German hands. German forces controlled both banks of the 50-mile-long estuary. Ships couldn't reach Antwerp until the river was cleared. That didn't happen until late November, after weeks of brutal fighting by Canadian forces to clear the Scheldt. Meanwhile, fuel shortages brought the Allied advance to a halt. British Field Marshal Bernard Montgomery's 21st Army Group in the north competed with Patton's Third Army in the south for limited supplies. Both commanders believed they could end the war quickly if given priority for fuel and ammunition. General Eisenhower faced an impossible choice: support one commander fully and let the other sit idle, or split resources and support both inadequately. He chose compromise, supporting Montgomery's Operation Market Garden, while also allowing Patton to continue limited operations. The decision satisfied no one. Market Garden, the ambitious plan to capture bridges in Holland and open a path into northern Germany, failed at Arnhem. Thousands of British paratroopers were killed, wounded, or captured. The northern route into Germany remained closed. Patton's army sat idle for lack of gasoline, unable to exploit its success. The temporary halt gave Germans time to regroup and establish defensive lines. The Siegfried Line fortifications along Germany's western border were manned and reinforced. Fresh divisions arrived from the interior of Germany. The Wehrmacht, which had been in disarray and retreat in August, reformed and prepared for defense. When Antwerp finally opened on November 28th, the logistical situation improved dramatically. Supplies poured through the Great Port. Trains carried cargo directly from shipside to frontline depots. The transportation crisis eased. But by then, winter had arrived. Cold, rain, mud, and eventually snow made operations difficult. And the Germans launched one final surprise offensive. The Battle of the Bulge, December 16, 1944. Germany's last major offensive struck through the Ardennes forest in Belgium. 3 German armies, 250,000 men, 1,400 tanks, 2,600 artillery pieces, attacked the thinly held American lines. The surprise was complete. Bad weather grounded Allied aircraft. German forces advancing in American uniforms and captured American vehicles caused confusion. The attack created a bulge in Allied lines, hence the name. The surprise attack created chaos in Allied rear areas. Railway lines that supplied forward units were now dangerously close to German spearheads. Some rail lines were overrun. Locomotives and freight cars were captured or destroyed. At the port of Antwerp, nearly 3,500 railway cars sat fully loaded, but idle. Engineers couldn't move them forward because the rail lines were contested. German V-1 flying bombs and V-2 rockets attacked Antwerp, trying to disrupt the port. 5 anti-aircraft gun battalions were reassigned as infantry to protect Antwerp in case of German breakthrough. The Battle of the Bulge lasted until late January 1945. American forces, despite initial setbacks, held key road junctions at Bastogne and Saint-Vite. The 101st Airborne Division at Bastogne, surrounded and besieged, famously replied "nuts" when Germans demanded surrender. Patton's Third Army turned north and relieved Bastogne after Christmas. The German offensive eventually collapsed from lack of fuel. German tanks ran out of gasoline and were abandoned. When it ended, Allied forces resumed their advance into Germany. But the railway engineers had lost 6 weeks of reconstruction time. Those 6 weeks potentially prolonged the war. Crossing the Rhine, March 1945. The Rhine River presented the most formidable barrier to Allied advance since the English Channel. The river was beyond 200 feet wide at some points. Fast-flowing current made fording impossible. The Germans had systematically destroyed every bridge across the Rhine. Explosive charges placed by retreating engineers dropped all the spans into the water, except one. At Remagen, American forces captured the Ludendorff Bridge, partially intact, on March 7, 1945. German engineers had attempted to destroy it, but the explosives only partially detonated. The bridge was damaged but usable. For 10 days, American troops and supplies poured across the Ludendorff Bridge. The bridge could carry infantry, trucks, and light vehicles. It could carry railway cars, but not locomotives. The damaged structure wouldn't support 120-ton locomotives safely. On March 17th, the weakened bridge collapsed into the Rhine, killing 28 American engineers who were on it making repairs. But by then, other crossings were underway. Engineers immediately began building replacement bridges. At Wessel, north of the Ruhr, a railroad bridge was completed in just 10 days. It was built using Bailey Bridge panels and American steel trusses, launched across the river using special launching equipment. Within a month of completion, it was carrying nearly 50 trains per day. The engineering achievement rivaled the Le Mans Railway. But this time, engineers were building bridges across the widest, deepest river in Western Europe while under occasional artillery fire and air attack. German aircraft, though few in number, occasionally attacked the bridges. German frogmen attempted sabotage, placing explosive charges on bridge supports. American engineers responded by dropping depth charges in the river and posting guards with automatic weapons to shoot at anything moving in the water. The techniques perfected in France, Bailey bridges, timber reinforcement, improvised signal systems, were applied on an even larger scale. By April 1945, railheads had been established at Stendal, Magdeburg, Leipzig, Regensburg, and Stuttgart, deep inside Germany. The Second Military Railway Service operated the largest railway network in the world at that moment. More miles of track, more locomotives, more freight cars, more tonnage than any railroad company in history. Trains ran on captured German tracks using a mix of American, British, French, and captured German locomotives. The polyglot railway system somehow functioned despite language barriers, incompatible equipment standards, different voltage systems, and heavily damaged infrastructure. American engineers operated German electric locomotives using instruction manuals hastily translated from German. French railway workers, now working for the Allies, operated French locomotives on German tracks. British locomotive crews operated American diesel switches in Belgian rail yards. It was organized chaos, but it worked. Victory, May 8, 1945. Germany surrendered unconditionally. The war in Europe was over. The Military Railway Service compiled its final operational statistics. Total railway mileage operated in all theatres, 22,000 miles. Total soldier railroaders who served, 43,500 men. Total freight transported in European theatre, 2.3 billion ton miles. That tonnage included every tank, every artillery shell, every gallon of gasoline, every ration, every bullet, every uniform, every medical supply that kept Allied armies advancing from Normandy to Berlin. Without the trains, the trucks alone could not have sustained the Allied advance. The arithmetic was irrefutable. Trucks could carry supplies 300 miles. Beyond that distance, they consumed more fuel than they delivered. Trains could carry supplies 3,000 miles efficiently. Without the Allied advance supplied by rail, the war would have lasted into 1946 or beyond. Estimates suggest that every month the war continued cost 50,000 Allied casualties, killed, wounded, missing. The railway reconstruction effort, particularly Colonel Itchner's 135-mile miracle in 75 hours, potentially saved tens of thousands of lives by shortening the war. After the war, the railway engineers received far less recognition than combat troops. Combat units received presidential citations, campaign streamers, battle honors. The Red Ball Express became legendary, justly so. Movies and books celebrated the truck drivers who kept supplies moving. But the railway service remained obscure. No movies were made about soldier railroaders, no songs celebrated the engineers who built bridges under fire. Few history books mentioned the 50,000 men who operated the largest railway system in the world. Most Americans never learned that former railroad workers from Union Pacific, Southern Pacific, Pennsylvania Railroad, New York Central, and dozens of other companies had served in uniform, rebuilding Europe's railways under fire. Colonel Emerson Itchner continued his military career. He served in Korea during that conflict, overseeing engineer operations. He eventually became Chief of Engineers of the United States Army, serving from 1953 to 1961. In that role, he oversaw major civil works projects and military construction worldwide. The Society of American Military Engineers created the Itchner Award in his honor, given annually to the most outstanding Army engineering company. But even Itchner rarely spoke publicly about the Le Mans Railway. In his memoirs, he devoted just 2 paragraphs to the operation. To him, it was simply doing the job that needed to be done. No more, no less. Just another engineering problem solved under deadline pressure. The train system that fed Allied armies across Europe was built by ordinary men doing extraordinary work under impossible deadlines. Men who had driven locomotives in peacetime now drove them through war zones. Men who had maintained track for civilian railroads now rebuilt track under fire. Men who had operated switching yards in American cities now operated them in French towns still smoking from combat. It proved that industrial democracy could outproduce and out-engineer any opponent. The numbers told the story. 22,000 miles of railway operated, 2.3 billion ton-miles transported, 10,000 engineers building 135 miles of track in 75 hours, 50 trains per day crossing Rhine River bridges built in 10 days. No single battle won World War II, but logistics won the war more certainly than any tactical victory. Generals plan battles, soldiers fight battles, but engineers and railroaders supply battles. Without supply, armies cannot fight. Without fighting, wars cannot be won. Amateurs talk tactics, professionals study logistics. Colonel Itchner and his railway engineers were the ultimate professionals. They never fired a shot in anger, but they delivered millions of shots to those who did. On August 15, 1944, when the first train rolled into Le Mans station at 11:45 p.m., the station master couldn't believe it had come from Cherbourg. The bridges were destroyed, he said. The route was impossible, he insisted. The schedule was insane, he protested. But impossibility is just an engineering problem, waiting for the right solution, and enough determined men. Patton's tanks rolled into Paris 10 days later, fueled by trains that couldn't possibly have gotten through. That's the forgotten story of World War II. Not just how battles were won, but how armies were fed, fueled, and supplied to win them. The railway engineers built victory one rail at a time, one bridge at a time, one train at a time. They did it in 75 hours when everyone said it would take 75 days. They did it under fire when everyone said it was too dangerous. They did it without recognition when everyone said it was impossible. And they changed history. 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 They changed history.